Space travel may be the most exciting and at the same time the most difficult adventure humanity has ever undertaken. But the strange part is this: the more we go into space, the more we risk reaching a point where we make ourselves unable to go into space at all. With every rocket we launch, with every satellite we place into orbit, we unknowingly pull ourselves into a trap. And this trap becomes more frightening with every passing year. If it is ever triggered to the maximum degree, it could destroy the space age and trap us on our own planet for decades, maybe even centuries. Sending something into space is incredibly difficult. To do this, you need to move very, very fast. First, you must go straight up and leave the atmosphere. Then you have to change direction and begin moving around the Earth. And yes, you still need to be very fast. If you succeed, you enter low Earth orbit, and this is where the interesting part begins. Once you are in orbit, getting out of it is at least as hard as getting in. If you don't have extra energy, you get locked there, constantly falling around the Earth. This is great for things we want to keep up there, like space stations and satellites. That's why we moved a large part of humanity's space infrastructure to this region, just a few hundred kilometers above the surface of the Earth. It's a place where the atmosphere is almost non-existent, yet orbiting objects can remain there for hundreds of years without falling back down. But this same place is also the source of our deadly trap. Rockets are essentially large metal cylinders carrying tons of fuel. When part of that fuel is used, the empty tanks are dropped to make the rocket lighter. Some of these parts burn up in the atmosphere or fall back to Earth, but most of them stay in space and begin orbiting our planet. After decades of space activity, low Earth orbit has turned into a massive junkyard filled with spent rocket parts, broken satellites, and shrapnel from missile tests and explosions. According to what we know today, there are around 2,600 non-functioning satellites in orbit, about 11,000 larger than a computer monitor, around 23,000 the size of an apple, roughly 520,000 the size of a marble, and at least 100 million tiny fragments that we can't even track. All of these are moving at speeds of up to 30,000 kilometers per hour, circling the Earth on intersecting orbits multiple times a day. At these speeds, being hit by a piece the size of a pea is like being shot with a plasma weapon. On impact, the debris vaporizes, releasing enough energy to punch through solid metal. In other words, we've surrounded our planet with millions of deadly bullets and placed $1 trillion global infrastructure right in the middle of them. Without this infrastructure, the modern world would stop working. Communication, GPS, navigation, weather forecasting, scientific discoveries, all of it depends on satellites. If a single pea-sized fragment hits one of the roughly 1,100 active satellites, that satellite would be destroyed instantly. This already happens 3 to 4 times a year, and in the next decade, both the number of satellites and the amount of space debris are expected to increase tenfold. We are approaching a breaking point. But the worst thing in space is not the small debris. The worst thing is a chain reaction. If 2 satellites collide just the wrong angle, it's not really a crash, but more like a splash. At orbital speeds, solid objects pass through each other, breaking apart into thousands of new fragments. These fragments then go on to destroy more satellites, creating an unstoppable domino effect. Collisions create more collisions, and the destruction grows exponentially. At first, it's barely noticeable. 1 year, 1 satellite is lost. The next year, 5. The year after that, 50. And one day, there's nothing left in orbit. The situation is getting worse fast, and we may already be past the point of no return. In the worst-case scenario, Earth could be surrounded by a debris field so dense and fast-moving that it becomes almost impossible to cross.
Moon bases, Mars missions, space travel as a whole could be delayed for centuries. But there may still be hope. That's why there are some wild but serious ideas for cleaning up space debris. Satellites that throw nets, harpoons, drag sails that use atmospheric resistance, magnetic tugs, even lasers. No matter which technology we choose, we need to start doing something, and soon, because before 100 million bullets turn into 1 trillion, we need to stop setting this trap. Otherwise, our adventure in space might end before it has truly begun.